Alright, so you want to have your calculator handy, especially when your answers are fractions. I know it's tough to work with fractions, but we have to verify these answers. So I'm going to show you something in the calculator that you might not have seen before. This only works for graphing calculators, especially when you have an ugly number like -1/9. So in order to verify, we're going to type in -1/9 in the calculator, and we're going to do something called storing it for x. Let me show you how to do that. So you're going to type in your number, -1/9. Be sure to use, sorry about the glare, be sure to use the negative button and not the minus button. Let me see if I can get that glare to go down. I don't think it's going to change. So -1/9. And then you're going to push a button that says STO. It's right above the on key, STO. It stands for store, and it has a little tiny arrow. So you're going to push that key. When you push that key, I know it's hard to see with the glare. Let me move and see. There we go. When you push that key, you should see a little arrow. Then you're going to choose the X key that we used earlier in the course, right next to alpha. So your number, the store key, and then X. And again, the store key is right above on. And that is STO with a little arrow. And then you're going to hit enter. What that does is it tells the calculator that every time you type X, it's storing the -1/9, and that's -1/9 is a decimal. So every time you hit X, that's what the calculator is using. So to check your answer, we can use that back in our original equation. So if I type in the square root, so second x squared of -10, and I can use the button X only because it knows what X is, -1, and then close parentheses or into the square root, and then plus 3x. If the calculator plugs in -1/9 for x here and here, and I hit enter, it should give me 0. And if it gives you 0, then you know that that answer has been verified. And I'm okay with you using this function all the time, but it's especially handy when you have a fraction for x that's just too difficult to work with. So that worked. We can do the same thing with -1. You can work it by hand, or you can store it for x. So you type in -1, then hit that STO button for store, and then X, hit enter. And then again, you're going to type that in, the square root of -10x minus 1, then make the square root stop or hit the parentheses to close it, and then plus 3x, and we should get 0 because it says it should equal 0. So you can do the same thing with -1, store for x, hit enter afterwards, and verify that it works. So they are both valid answers. You don't have to use that function in the calculator, but it sure does help, especially when you've got ugly numbers. Alright, so let's try another one that's quadratic, where you get 2 answers. This is example 6. We have the square root of 16x minus 3, and then, sorry, that should just say minus 4x equals 0. Sorry about that. That should just be a minus sign. The square root of 16x minus 3, then stop the square root, minus 4x equals 0. I encourage you to pause the video and try this one on your own. Don't forget to verify once you're done. So for this one, the first thing we need to do is move that 4x to the other side. It gives us the square root of 16x minus 3 equals 4x. From there, we can square both sides. That's 16x minus 3 equals 16x squared. We have a squared term, and anytime we have a squared term, it's called quadratic. And we want to move everything to one side. Now, generally speaking, you want to keep your x squared term positive. You don't want that to be negative. It's easier to factor if your x squared term is positive. So it's generally the best idea to move all the other terms to the x squared term. So I'm going to move the 16x and add the 3. Subtract the 16x and add the 3. Should give me 0 equals. You want to put the x squared terms first, then the x term, then the constant term. Then we're going to factor. So we have A, B, and C. There's no GCF. So 16 times 3 is 48. B is negative 16. So I need two numbers that multiply to 48 and add to negative 16. Those two numbers would be negative 12 and negative 4. The two negatives will cancel out, but they'll still add to negative 16. So that's 0 equals 16x squared minus 12x minus 4x plus 3. So if we look at the GCF of those two terms, that would be 4x. That would leave us 4x minus 3. The second two terms, we're going to take out a negative 1. That will also leave 4x minus 3. So my factored form is 4x minus 1, 4x minus 3. You're going to take each of those linear factors and solve for x. That should give you x equals 1/4. 4x minus 3, that should give you x equals 3/4. So you have two answers to verify. They're both fractions, so again, I recommend letting the calculator help you out. So we're going to type in 1 divided by 4 and store that for x. And then we'll type in the original equation and see if it equals 0. So the square root of 16x minus 3, then you want to stop the square root or close the parentheses, minus 4x. That should give us 0, and it does. And now we're going to do 3/4. So 3/4 store for x, and then type it again, the square root of 16x minus 3, and the parentheses or close the parentheses are in the square root, and then minus 4x, and we're hoping that gives us 0. If it doesn't give you what it should equal, then it's not valid, but those two are both valid. All right, so there's a couple quadratic. I want to look at some more quadratics, and then we'll get into just a couple more examples. All right, that was example 6. So now we're on to example 7. We have the square root of 4 minus x equals x plus 2. Again, I'm going to write verify here so I don't forget. So the radical is already isolated, and so I can just square both sides. When I square the side with the radical, all that does is undo the radical. The square and the square root cancel each other out. On the other side, I have a binomial. I have two terms instead of just one term. So it's very important that when you have a binomial squared, you have x plus 2 times x plus 2. That means that you're going to have x times x, x times 2, 2 times x, and 2 times 2. So you have 4 minus x equals, that should give you x squared. You're going to have plus 2x and plus 2x again. So that's plus 4x, and then 2 times 2 should give you 4. So once again, anytime you have a binomial squared, it's very important to write it twice. That's what squared means. Write it twice and multiply it out. You should be getting pretty good at that by now. Then we kind of look at what we have. Is it linear? Is it quadratic? So here's my squared term. That indicates that it is quadratic. So what we're going to do here is move everything to one side. So we're going to move that 4 and add that x. I'm going to line up the minus 4 under the constant term and then add the x to the middle term. So you can only add and subtract like terms, and you can kind of line them up appropriately. So we have 0 equals x squared plus 5x, and then plus 0. These two 4's zero out. So all you really have is x squared plus 5x. My next step is to factor, but I don't have a trinomial and I don't have a difference of squares. When you feel stuck in factoring or it looks kind of off, remember GCF. That's always your kind of fallback. If you're like, I don't know what to do with this, look for a GCF. Sure enough, there's a GCF of x. That leaves you with x plus 5. That gives you two linear pieces, which is what we're trying to get. From here, we have x equals 0, that's one answer, and we have x equals negative 5, that's the other answer. Now our job is to verify. You can verify these by hand and plug them in, or you can verify them in the calculator. 0 and negative 5 aren't too bad, so I'm going to just go ahead and do this by hand. For x equals 0, we're going to plug in 4 minus 0 and see if that equals 0 plus 2. 4 minus 0 is just 4, 0 plus 2 is just 2, the square root of 4 is 2. That's verified. Now let's try negative 5. Square root of 4 minus negative 5, I need to see if that equals negative 5 plus 2. 4 minus negative 5 is 9. Negative 5 plus 2 is negative 3. The square root of 9 is always defaulted to be the positive 3, and it's not the same as negative 3. So that is not a good answer. There's only one good answer for this one. So sometimes they both work, sometimes neither of them work, sometimes only one of them works. Alright, let's try another one like that. I encourage you to try this on your own. This will be example 8. Let's do the square root of 16 plus x equals x plus 4. I encourage you to pause the video and try this one on your own. And don't forget to verify. Alright, so the radical is already isolated. I just need to square both sides. This is 16 plus x. Once you work this out, remember it's x plus 4 times x plus 4. You should get x squared plus 8x plus 16. And then as soon as you notice that you have a quadratic term, you want to move all pieces to one side. So I'm going to move that 16 and move that x. So I'm going to move the x and move the 16. Gives me 0 equals x squared plus 7x, and sure enough these zero out again. So we really just have x squared plus 7x, which doesn't happen often, but every now and then it just kind of, your trinomial breaks and you don't have that constant term. So again, when you feel stuck, look for a GCF. That would be x times x plus 7. This gives us x equals 0. This gives us x equals negative 7. So those are our two answers. Now we need to verify them. So in order to verify, I'm going to plug in 0 first. That's an easy one. The square root of 16 plus 0, I need to see if that equals 0 plus 4. That's the square root of 16, and it does equal 4. I'm going to plug in negative 7. 16 plus negative 7. See if that equals negative 7 plus 4. 16 plus negative 7 is 9. That's negative 3. And we always assume the positive root, so that doesn't work. Now that's not to say that x can never be negative. It's just that in these situations it wasn't working out. So this is not valid. And the only answer you would put in my math lab are the ones that actually work out. So x can be negative, it just depends on what the equation looks like. Alright, let's look at two more. Just about there. Example 9. We have the square root of x squared plus 4x minus 20 equals x. And again, I'm going to write down verify over here. So the radical is already isolated. All I have to do is square both sides. So that's x squared plus 4x minus 20 equals x squared. Now I have x squared terms, but you notice you have the same x squared term on both sides. And so if I were to subtract x squared from both sides, they would zero out. So I really just have 4x minus 20 equals 0, which means there's no more x squared, and this becomes a linear equation. So I'm going to add the 20 to the other side. That gives me 4x equals 20. Divide both sides by 4, and x equals 5. Now I'm going to verify that answer. You're going to plug in 5 everywhere you see x. So we have the square root of 5 squared plus 4 times 5 minus 20, and I need to see if that would equal 5. So 5 squared is 25 plus 4 times 5 is 20 minus 20. Positive 20 and negative 20 zero out, which is just the square root of 25, which is 5. So that is a valid answer. All right, one last problem here. Example 10. I encourage you to pause the video and try this one on your own. We have the square root of x squared minus 3x plus 3 equals x minus 1. Don't forget to verify. So again, I encourage you to pause the video, work this one out as best you can, verify your answer, and then play it back to see how you did. The radical is already isolated, so I can square both sides. That's x squared minus 3x plus 3 equals, now x minus 1 squared is x minus 1 times x minus 1. So we have to work that out. So that gives us x squared minus 3x plus 3 equals, this should be x squared minus 2x plus 1 when you're done. Now again, we have x squared on either side, and if they're the same on both sides, they're going to zero out. So if I subtract x squared from both sides, they are both canceled. So I really just have negative 3x plus 3 equals negative 2x plus 1. So I think I'll add 3x to both sides. You can solve this however you want to. That would be x plus 1, and then I'll move the 1. You should get x equals 2, and you can be comfortable solving that in whatever order you want. You should get x equals 2. Now we need to verify that. I don't know if I gave myself quite enough space here. I'm going to do the square root of 2 squared minus 3 times 2 plus 3, and I need to see if that equals 2 minus 1. So 2 squared is 4 minus 6. 4 minus 6 is negative 2 plus 3. So 4 minus 6 plus 3, and 2 minus 1 is 1. So 4 minus 6 is negative 2 plus 3, which is 1. And you can use your calculator if you want to. So that number is a valid answer. All right, that is solving radical equations, both linear and quadratic.